modulating SPM interferometry methods are used. This is a research problem. In this paper, a measurement method to determine the surface shape of an ingredient outside the plane coated the transfer plate was proposed. Firstly, the phase error due to the transfer plate planes were formulated. To determine the phase error precisely, the reflectivity transferability were measured by the mathematical modeling. The phase difference was determined by the phase shifting algorithm, comprising the polynomial window functions and decreased Fourier transform. Finally, the surface shape of the indentating outside template coated transfer plate was measured using sinusoidal phase modulating interferometry. This slide is the objectives of the research. The research challenge in this study is technique on the surface shape measurement for the indentating outside ideal thin planes using the conventional technologies. The width out of this research challenge is to measure the shape of the thin planes based on the sinusoidal phase modulating with interference signal, error values, and shape values in the nanometer range. This is a flow diagrams of the research. Firstly, the helium-neon laser beam strikes the beam splitter. The beam splitter is split into the two beams. One beam is the reference mirror and is driven by the physio transducer PZD and it's a reflector path. It's called the reference wave. And another beam is the reflector object and reflector path is called the object wave. The object wave and the reflector wave to combine and to form the interference signal. The interference signal is interference signal is detected by the image based on the CCD camera, camera and CCD both. The image data is imported to the computer and stored in the MATLAB simulation. And therefore, we can update the interference signals and the surface profile in the research. Next slide shows the implementation of the research. This figure shows the multiple reflection of the thin film. This is the flow diagram for implementation. Firstly, from the simulation, we gather the interference signal S or D. From the interference signal, we gather the intensity with amplitude D. And from the D value, we calculated the phase difference and phase error data and phi. And from the phi value, we calculated the alpha value and psi value. The psi value is the surface profile. It is a constant in this research. This is a sample pattern with the various values of alpha. This figure is the interference figure, and this figure is the first Fourier transform figure. And the interference signal is changed into the first Fourier transform. It's separated into first omega c, second omega c, and third omega c. The amplitude wave and the amplitude wave G and the phase distribution error are calculated from the first omega c and third omega c. In this figure, the first omega c and third omega c are larger than the second omega c. This is a very important in the research. This is a interference signal pattern for alpha is equal to 0, alpha equal to 5.4, alpha equal to 5.2, for alpha equal to 3.54 in this research patterns. These are the given data values in this experiment for reflectivity R, transmittivity D, and the reflector index and values are the values used in these experiments. Next slide shows the research. According to the research theory, the values of data and the resulting data get and the values of phi and the resulting data get are the same. So T equal to the thickness 50 nanometer is chosen as the best surface shape of the to measure the surface shape of the indenting outside thin film. And so T not 50 nanometer data get at the same, phi and phi get at the same. This is a research interference signal for T not is equal to 50 nanometer and no error values of A and B. And this trigger is the interference signal, and this trigger is the first Fourier transform triggers. And this is the simulation of the pictures of indenting outside thin film object and glass plate. Firstly, this image is indicating outside thin film. Like this, this is yellow portion in the indicating outside, and the green portion, the blue portion is the green. The blue portion is the glass plate. We know at this point between the yellow and the blue color. This one is nearly about -2, and we remember this value and we use in this experiment. That this is the important region adjustment, and this slide show the 3D views on the object, and this is the top views on object. And this portion is the indicating outside, and this portion is the glass plate. Normalization. This figure shows the normalization D. The normalization D shows the mixtures of the indicating outside and the glass plate. And this figure shows the cos theta figure. Cos theta precisely must be precisely between -1 to 1. And so in our result, after simulating the cos theta between, we got the cos theta between the -1 to 1. So this is justified in this experiment because this cos theta must be precisely between the -1 to 1. The picture, so this slide shows the pictures of finite surface distribution and surface profile. And this is the thickness profile. We are the real value T naught equal to 15 nanometer, and in our result we are used. And after simulating, the thickness is nearly about 15 nanometer. So the real value and after the simulating result are similarly the same. So this is the difference in this experiment. This figure shows the finite surface distribution. This is the finite surface distribution, and this is the last figure of the intersurface surface profile figure. Surface profile is slightly smooth and flat. So this figure, after the result, this figure is smooth and flatly. So this is justified in this experiment. This is a random measurement result for surface distributions of the indicating outside thin planes. And this is this figure, and after the result is not chosen because there is not unstable condition. Let me conclude my presentation. The distance of this experiment is confirmed. The performance calculating result for the measurement accuracy. According to the study at the experimental hardware, the interference signal was obtained. So the interference signal is very important in this research because it is very important. The signal by using with the Church-Gurger device CCD was detected and imported data to PC for tracking. The data signal and software was captured and saved as the imported data for mallet simulation. And so the system was simulated by using the imported data using the ACAP software. ACAP software was captured the import image data. And so the fringe pattern is difficult to capture because of the short wave coming out of the air conditioner and vibration of the effects. Thank you very much for your attention. Please give